Hi, I'm Mudinda and I'm here to help you understand maths better for free. Well, today we're continuing with our factorization topic. This is meant for grade 9s, 10s, 11s, and 12s to understand factorization better. And today we're looking at the difference of two squares, a very particular method of factorization. Now, you can only apply this method when you have two perfect squares that are separated by a minus. And I wanted us to start off by just chatting about what a perfect square is. When it comes to numbers, a perfect square or perfect squares are very specific. They're numbers that result from squaring a number or multiplying a number by itself. So numbers like 9, 25, 36, these are perfect squares because 9 can be written as 3 squared and 25 can be written as 5 squared, 36 can be written as 6 squared. So these are perfect squares. A number like 10 is not a perfect square. A number like 12 is not a perfect square. When it comes to variables, any variable with an even exponent is a perfect square. As long as the exponent of a variable is an even number, then that variable is a perfect square. So variables like x squared, that's a perfect square. A variable like x to the power of 4, that's a perfect square. X to the power of 6, that's a perfect square. X to the power of 10 is a perfect square. But 6 as a number is not a perfect square. 10 as a number is not a perfect square. Now, here's an example that's going to illustrate how to factorize using this method. If we were given x squared minus 4, these are two perfect squares separated by a minus. This is a perfect square because it's a variable with an even exponent. This is a perfect square because it can be written as 2 squared. You're going to open two brackets. Here you're going to put the square root of x squared, which is x. Here you're going to put the square root of 4, which is 2. Then you're going to put a plus and a minus. You're done. You've just factorized using difference of two squares. What if we had a squared minus 9? We would open two brackets, would put a here and a there, and the square root of 9 is 3, so we'd put 3 here and 3 there, a plus and a minus. That's now factorized. You can try to simplify this and see if you get the question back. Because remember, like we said, factorization and simplification are opposites, and so we can always simplify our answer to see if we get the question back, and if we do, that's when we know we've factorized correctly. We've spoken about how to multiply out binomials or how to simplify two binomials like this. If you struggle with it, I do have a video on it that you can watch. But let's try to simplify this, see if we get our question back, to see if we factorized correctly. A times a would be a squared. A times negative 3 would be negative 3a. 3 times a would be positive 3a. And 3 times negative 3 would be negative 9. See, minus 3a plus 3a is 0, and I left with a squared minus 9, which is what the question was. And so we know we factorized correctly. And this is how we know that the difference of two squares is a valid method of factorizing, because when we simplify it, we do get the question back. Here's the next one. Y squared minus 100. Would open two brackets, would put y here and y there. And the square root of 100 is 10, so we'd put 10 here, 10 there, put a plus, and put a minus. That's how to factorize using the difference of two squares. What about x squared minus 1? Is this a difference of two squares? Well, x squared is a perfect square because it's an exponent with an even exponent. 1 is also a perfect square because it can be written as 1 squared. Remember, 1 squared is just 1 times 1, which is 1. So 1 is a perfect square. It's the square root of 1 is 1. And so we're going to open here two brackets. We'll put x, we'll put x, we'll put 1 and 1. Then we'll put a plus and a minus. Great. What about 4x squared minus 25? Well, is this a perfect square? Yes. The square root of 4 is 2, and the square root of x squared is x. And so for that reason, here we're going to put 2x, and here we're going to put 2x. Here we'll put 5 and 5, since the square root of 25 is 5. We'll put a plus and a minus. Awesome. Let's look at some more examples. What if you had x squared minus y squared? You can go ahead and try to write out the answer on a piece of paper and compare it with ours. But the answer is x, y, and y, a plus and a minus. Remember, the square root of x squared is x, and the square root of y squared is y. What about x to the 4 minus 9? Here, we're going to open two brackets. But since we have x to the 4, the square root of x to the 4 is actually x squared. It's not x, but x squared. In fact, a very interesting part of variables is that the square root of a variable is just that variable and half of its exponent. So the square root of x to the 4, right, is just x squared. The square root of x to the 6 is just x to the 3. And the square root of x to the 10 is just x to the 5. The square root of 9 is 3, so we put 3 here and 3 there, put a plus, and we put a minus. Great. What about this example? X to the power 4 minus 16. I've put this example here because it teaches us a very important lesson. Have a look. I'm going to open two brackets and I'm simply going to put x squared, 4, and 4. This is because the square root of x to the 4 is x squared, and the square root of 16 is 4. Plus and minus. You might think, great, we're done, but I want you to focus in on this bracket. What do you notice about this bracket, if you notice anything? Well, what I want you to notice is that in itself, x squared minus 4, is a difference of two squares. X squared is a perfect square, 4 is a perfect square, and there's a minus. So that can be factorized. It's a difference of two squares. So what we do is we add one more step. We'll leave the x squared plus 4. This can't be factorized because it's not a difference of two squares. That requires a minus, okay? But this can be factorized, and so we then again open two brackets like this. This time we'll put x, 2, put a plus and a minus. We are now done factorizing. So it's very important to check when you're done factorizing if a question can be factorized any further. So what if you had x to the power of 8 minus 1? Well, we're going to open here two brackets. We're going to put x to the power of 4 plus 1 and x to the power of 4 minus 1. But hold on, this is the difference of two squares again. So x to the power of 4 plus 1, and here we can open two brackets. We can put x squared and x squared, 1 and 1, plus and minus. But hold on, this again is a difference of two squares. So we have to keep going again. X to the power of 4 plus 1, x squared plus 1. Then we're going to have x, 1 and 1, plus and minus. We are finally done because we no longer have a difference of two squares. This is not a difference of two squares because x is not a perfect square. A variable is only a perfect square if its exponent is an even number, and the exponent of x is 1, which is an odd number. We're finally done factorizing that. So you have to be very careful to check that you have factorized fully. Great. This example is very, very important. It says 2x squared minus 50. Is this a difference of two squares? Well, I hope you said no. 2 is not a perfect square. The only numbers that are perfect squares are numbers that come from squaring a number. There's no number that you can square to give you 2. Because 2 is not a perfect square, this entire thing cannot be a perfect square. Is 50 a perfect square? No. If you try to find the square root of 50, you won't get a whole number. So this is not a difference of two squares. How can we factorize it? Well, I hope you remember from last time, we learned about how to take out a common factor. Is there a common factor here? Yes. That common factor is 2. When you take 2 as a common factor, here you'd be left with x squared. When you take 2 as a common factor, then there you'd be left with 25. If you don't know how to take out a common factor, I suggest you watch my video on common factor factorization. Now, this is a difference of two squares. X squared is a perfect square, 25 is a perfect square, and there's a minus between them. So we factorize that using difference of two squares. We'd put x and x, 5 and 5, would put plus and minus. Now, if you are very curious, you can try to simplify this and see if you get the question back. Remember, in your test, that's how you can confirm that you factorized correctly. Great. Here's yet another example. 100 minus b squared. These are both perfect squares. The square root of 100 is 10. The square root of b squared is b, plus and a minus. What about 81 minus p to the 4? These are both perfect squares. The square root of 81 is 9. The square root of p to the 4 is p to the 2. It's p squared, plus and minus. But hold on. 9 minus p squared is also a difference of two squares, because 9 is a perfect square and so is p squared, and they're separated by a minus. So for that, I can open again two brackets. The square root of 9 is 3. The square root of p squared is p. I can put a plus and a minus. Great. One more. What if you had a plus b squared minus 1? Why don't you pause the video and give it a try if you have an idea? If you don't have any idea, let's chat about it. Here, we have a plus b squared. What is the square root of that? Well, square root signs and squares cancel out, and so the square root of that is just a plus b. So that can be seen as a perfect square. 1 can also be seen as a perfect square because the square root of 1 is 1. So what we can do is we can open two big brackets like this. And here we can put the square root of a plus b squared, square root of a plus b squared, which is a plus b. Then here we can say plus 1 and minus 1. I hope this lesson makes sense. See you in the next one where we talk about how to factorize trinomials.